G'day guys, got this very old GP Extreme. It's been kicking around. It actually caught on fire. It actually, you can see there, it actually burnt the whole back of the board out. It caught on fire. I've rebuilt it. This was just sort of a side job I was half doing, and I sort of went, shall I continue on? So yeah, I've rebuilt him after he's burst into flames. It needs a few things done to it, but the GP Extreme, even though this one, I don't know where the front panel is, I think it may have, I don't know, gone up in smoke. I got no idea, but that's how it is. It was a complete write-off anyway, so I've labelled the switches what they do. And with the GP Extremes, they are a very, very good detector. But they have one thing that lets them down, and it's not because of design fault, it's because what was available at the time of manufacture. And if you have a look, I'll get something pointy and pokey. What can I use? How about I use a screwdriver? There we go. I've got to be careful too, because I just had power on this, and if you short anything around this area here, it will blow up the driver transistor to the two MOSFETs here, so you don't want to do that. And also it can take out the other. On this one it has secondary P-channel MOSFETs. But I'll zoom in a little bit. I'll actually just move the camera in a little bit. You see those things there? One's black, one's white. I actually just scraped the paint off, so if you could see it, you could actually see the number there. I'll zoom in, see if you can see the number. Here we go. It's a BSP121. Both of those devices are BSP121s, and that is doing the isolation for the flyback voltage, which is limited by the feedback circuit and clamping circuit to 185 odd volts. And these, I'll tell you right now, you want the biggest performance increase in the GP Extreme or anything. See those two MOSFETs there? Remove them and throw them in the bin, right? They are slugs. They are very high capacitance, and they don't have a very substantial low on resistance. And the other thing about them as well, I don't think they're DMOS, as in vertical channel type low noise structure MOSFETs. I think they're just old planars, and they're bloody noisy as hell. They introduce noise, and if they've got high gate capacitance, they're very hard to switch on fast and off fast. And also the other structures as well, the drain and source, 2 gate, you can get signal leakage, and all sorts of things. You can get, with high gate capacitance, you get gate modulation affecting the signal. You've got to be very careful on the layout and the way it's all designed. These devices as well suffer from metal migration. I've replaced a lot of these over the years, believe me. They fail. They just, for no particular reason, because they're switching on and off so fast, they do get quite hot, and they're stressed out pretty close to their 200 volt rating. They fail. All you need is very small transients to get past the clamp circuit. Just like make and break of coil connectors, and they can generate a lot of voltage, and you may not see it. Even, well, I had to use a 1.5 gigahertz oscilloscope to catch the glitches at higher than the 185 clamp voltage, and it does. You can actually see it if you look. It's in the picosecond area. It's very fast. Normal oscilloscope won't pick it up, but it just somehow, when you make and break coil connections, or it gets noisy or dirty, it does something, and these things just fail. It takes them out. And also when they fail, it'll take out, if I remember rightly, where is it on this thing? I'm trying to remember where it is. Well, it's got a driver transistor there somewhere. Maybe it's down here further. Can't remember. That other one there, that should get the flick as well, and put in a decent damping MOSFET as well. Something new. I think it's the same as those. Looks like it, doesn't it? but they're slugs, and not really that it matters there too much, but you know, there's a lot more newer modern components around than that. But yeah, I haven't worked on one of these for ages. Let me have a look, see. Where's the driver for it? I can't remember. You know, come to think of it, it's right next to the transistor. That might be the P channel. Well, it's not actually, I shouldn't call it a driver. It's a fast turn off. So anyway, it blows that up as well, that thing, right in the middle of the screen there next to the transistor. So, well, MOSFET. I keep calling them transistors. Well, they are, but they're not. They're really MOSFETs. They're a little bit different. Yeah, as you can see, the old white paint everywhere. But yeah, get rid of those things there. Flick them out. You can also get much better P-channel ones for the other side of the board near the... you make sure it's got AD797s in it. I'm not sure, but I think possibly very, very early on. This is just going back years and years and years. These things came out somewhere in the 90s, so it's a while ago. I'm just trying to think back. Man, I'm going to flick it round. I've got to flick it around to see this. You got to be careful doing this. Look how dirty this thing is. Like I say, it did catch on fire, but look at the dirt. My God, I think it was operated without the front cover on it. Yeah, it's absolutely filthy. Dirt's got in there, and that's the other thing that fails too. These ribbons. If I can get my, where am I? Can't even see where I'm sticking my finger. So I've got this zoomed in, haven't I? See those cracks there? That's the weak point. You bend this, it'll break the ribbon along those cracks, along the fracture lines. That's where they break, where those fracture lines are. If you move it back and forth, it gets rid of the gentle radius and puts a sharp edge, and it will fail. So that's that. Okay, we've got to get down here. Where am I? Still zoomed in. Okay, under the wires there, and just move them over there. Okay, I think NE5534s, where those two op amps are, if they're those devices, flick them out, put a couple of AD797s in there. It will make it a world of difference how the detector operates. So the other thing too, if I remember rightly, okay, we'll get my pointy object here. How about I don't want to zoom in so far, it's bloody confusing. But say here, that's a BF908 there, that one, and one there as well. When these things go out of their normal receive cycle, and it's gone to transmit, it actually disconnects electronically through the MOSFETs. It disconnects the input to the op amps, and it doesn't have a bias return, and it will technically look like it's open circuit, and doing that will turn to a power oscillator. So you don't want that, and that's why they have these BF 90, I think they're 908s from memory, 908, yeah, BF 908s. They're just dual channel MOSFETs. They do a dual channel. It overcomes Miller effect and doesn't really affect the devices when they're in receive mode. What else was there about it? I think from memory, can't remember which one's which. That's a BAV99, and that's one of the P channel MOSFETs, or it might be the other way around. See, it's all covered in white paint, and I just can't remember. I know, just to poke the legs and find out what's what, find out what goes to pin 3. Actually, they all go to pin 3 because protection. Dear me, gee. And it's exactly identical on the other side as well. One's a BAV99, one's a P-channel MOSFET. I can't remember what the P-channel MOSFET is off the top of my head. Some Philips device. Flick it out, get a ROHM device in there, one of the new, what is it, 2N7002BK devices. They have a very, very low capacitance and a very, very low on resistance. Much better device, less resistive losses as well. Not that it makes much difference, but you're talking something between going from 6 ohms on one of these down to about half an ohm. If the newer devices are much better, so yeah, check those. They got it. You can always tell what they are. The AD797s have a completely flat underside. There is no identification marks or anything, or holes or whatever. They're just flat, right? That's how you tell the difference between some cheaper type op amps and the really good ones. The AD797 should have a bevel on the front edge here, and that one there, relatively flat down to the pins there. Be careful if you take them out to check, because they're glued in, right, with something like super glue, and if you heat it up too much and then flick it, it'll ripple the tracks off. You've got to be very, very careful. Don't heat it up too much that you damage the chip as well. So you got to scrape all the white paint off so you get good thermal conductivity. Don't use hot air. Fill it up with solder, both ends, both sides, back and forth, get the temperature even. Eventually it will come off. Give it a bit of a light touch with a very, very small flat blade screwdriver or something of that nature, or even something very pointy. Whatever you've got, don't push it that it pulls on the tracks. Just touch it like so, and then it will move. When it moves, heat it up very quickly on the legs and then flick it off the board. So you got to be careful. It will destroy the lamination of how the tracks are put on. It'll unglue, it'll rip them off. So be very, very careful doing those. But these very old detectors with, well, I'm just looking at it now, I'm just thinking there's heaps of stuff you can replace. Right? There's a lot of stuff that can be replaced. Yeah, you can play around with all sorts of things here. You can redo some of those capacitors there. You can double the size of those, make it more smooth. You want to, yeah, little ADC sitting there. So yeah, that's what this gadget is. Look at that big power MOSFET sitting there in the middle of the screen. It's an SGS Thomson device for memory, and they actually blow up. I can't work it out. 200 or 250 volt rated, and it's rated for something like either 20 or 25 amps, and the detector's running under 1 amp. It still blows them up. Goes short circuit. It happens quite often. And the one behind it does 15 volt pulses, and that also can go short circuit as well. The big fatty does a 5 volt pulse for the transmit. And what else we got? Oh, that thing there, that goes short circuit too. 200 volt rated MOSFET. So yeah, I've replaced many of those over the time, and now when I replace them, I put a 240 or 250 volt rated MOSFET in there. That takes care of that. But yeah, you know, look at that inductor there on the transmit. Oh, sorry, not the transmit, but it's actually sets up the timing. The timings for this, for the transmit receive cycle, are done by inductor and capacitors, and you know, basically, well, an LC oscillator, and everything else is, you know, clocked off that. Could have done it digitally, but not. It probably, well, actually, I know why they do it. It gets rid of phase jitter. But anyway, you should all know that. Well, maybe you don't, I don't know. But yeah, so yeah, on these detectors, you want to resurrect them. Get rid of those two big fatty MOSFETs. Get rid of the two old P-channel ones. These are P, by the way. The later model detectors have N. It's just a different configuration, how they make it work. But yeah, you can make these really, really good. Very, very sensitive. Do a few tricks to it and a few modifications. They come up really well. But this one definitely needs a front panel. And it also needs those devices removed. And I'm only holding the phone this time. I haven't got it on the tripod. So I can't desolder those one-handed. So I'm going to have to disappear and get into it. But yeah, it's just... I thought that I'd just get in and just finish it off. It's been staring at me for a long, long time because it was a complete write-off. It was just absolutely chewed out. Yeah. So that's the GP Extreme, and it's been an extreme repair. There you go. So it's missing knobs and everything. It's in pretty bad way, but you know. Be good if I actually had the front for it. Ah, dear me. If anyone's got a smashed up this or burnt up Extreme, yeah, if you don't want the front panel, let me know. I think I might have a box for it. I've got some crazy busted detectors here which have been run over. People put their detectors behind their four-wheel drive, all right? Forget about it and reverse and run over the detector. And I've that just pancakes the whole thing. It's a write-off. Yeah, I've had all sorts of funny stuff. One that got caught in the floods, been underwater for 3 weeks. Got that going though. It's in one of my videos in the early days. All good fun. Anyway, that's the GP Extreme. See one of these going cheap. Should pick it up. They can be very, very good. They got a sensitive mode. If you have a look on the front, I'm pretty sure it's there. Not there. It's got shallow and deep. It's not that. If you put it in shallow, it makes it feel. It's really funny. It's a funny effect. It gets like the warbles, very fast, choppy, warbly sound. And you know, I don't know anyone's used it in shallow. I always use them in deep. Mellows it out. But a lot of people use it in normal. So, but I don't know anyone use it in shallow. I think you'd miss signals with shallow, just because it's going making a whoppy whop sound in the background. Yeah. Anyway, that could be of use to someone if you pick up one of these things cheap. You know, look at it. Needs a wash. You know, I have washboards like this before. I scrub them. Put them in a kitchen sink. Put some dishwashing detergent in there, and I scrub the hell out of it with a toothbrush. Then I rinse it with deionized water or filtered water, right? And I put it in the oven at around about 100 degrees C. And I only do it for a short amount of time until it heats the board up, and take it out and let it dry naturally as the heat dissipates off the board. And you just get rid of all the water off it. It works fine, works like a charm. There's no harm in doing that, unless you've got onboard batteries, and which these don't, or some sort of capacitive charge volatile memory, which these don't, or anything like that. You just got to be careful, make sure that what you're doing that to doesn't have any tricks that'll stop it working. But these clean up okay. So anyway, that's the God. How old's this detector? Come on. Yeah, 20 years old or so, maybe more. We had a funny. I've got to tell you this. Actually, we had a funny one, right? Fellow rang up and said my detector stopped working, right? And he said it never worked. I went, okay. Well, David actually spoke to him, not me, but I was getting it off David. It never worked. You looked at it and it stopped working. It never worked. And I went, okay, yeah, okay. Saying it stopped working. Okay. And yeah, it never worked. I want you to fix it. So found out, went back through my books. It's the detector is nearly 30 years old, right? And the last time I looked at it, right, was in 2016, right? So I think what he was trying to do is make some sort of warranty claim on a detector that suddenly stopped working, right? And it's basically was looked at 10 years ago. So I thought that was quite amusing. Yeah, but then it was thrown in, oh, it never worked, but then it stopped working. Okay, righto, that doesn't make sense. So we get funny stuff like that, you know, like the old guy who a while ago, oh, this is years and years ago, kept on, he had a variable supply on his SD 2200. I said, do not ever take the voltage past, you know, pushing it 7.4 volts, you'll blow up a little MOSFET and switch mode power supply. And freaking hell, what do you think he did? He tries to crank it up, getting extra grunt out of it, and blows up the bloody MOSFET. You can tell straight away it's the same MOSFET every time. And I said, don't adjust it, leave it as it is, you know. And on the third time, he did it. And I said, I'm teaching you a lesson, I'm not fixing it. You keep doing it. I know what you're doing. You're turning it up. And because when I got the thing, I look at where he's adjusted to bloody 8 volts or something, you know, and it's just going to blow up. So I felt like putting a string of diodes in the input lead or something of the power supply, but that's not very good. So yeah, I refused to fix it. I said, no. I said, you're just going to do it again. You're wasting my time. So yeah, he swore black and blue he wouldn't turn it up again. So yeah, I did fix it, and I put a big like a back-to-back diode Movista Zener clamp across the input. So yeah, never heard back about that one. So I don't know, maybe he blew his power supply up. But yeah, with these detectors, don't do weird things to them, and then, you know, say that it never worked and stuff like that. Just doesn't sound nice, and it's just yeah, it's just I don't know, what do you want to call it. I'm going to be nice. I'm not going to say anything more than on that, but yeah, that's the Extreme. And the same goes for a lot of these detectors. Early 3000s also have those BSP 121s in the front end. Yep, get rid of them. Oh, the other thing too, please remember this. Discharge both that one and that one. Mainly the 15 volt one, discharge it. Short it out. With the detector not connected, by the way. When the detector's sitting like that with nothing on no connection to it, right? Short those out on the back, the 2 pins. And to be careful, very careful, sometimes these things don't bleed off and you'll get belted, or it can do damage to the detector. Short that bloody thing out as well. That is 220 microfarads, and it has about close on 185 volts. Sometimes it can be higher. If that thing there goes open circuit, I have found 240 volts DC across this. The capacitor will hold it for a while. You touch it, you're going to know about it. Don't risk it. Always short those things out, just in case it doesn't bleed off. If that goes if that goes open circuit, well, guess what? It's not going to bleed off. So just be careful with these detectors. They will bite you if you're not careful. The rest of it's all safe. You know, these caps, anything here, anything over on that board, safe. This is the bitey end here. That is all bitey. Under the board and on top of the board, don't touch anything. You know, just be careful. Don't touch the wires and touch that. It'll bite it'll throw you off your chair, put it that way, if you get it in the right charge level. So be careful with these detectors. I've said it a few times in videos, and I keep saying it just in case someone sees one of these videos and says, oh, okay, we'll do that, and yeah, they don't know. So that's the disclaimer from touching these. Be careful about the capacitors. It stores charge, it stores a stack of high voltage electrons that want to race through your body. So watch out, don't work on them without discharging the capacitors. And the way, what I do, I'll show you how I discharge them. I'm not going to actually do it, but I get just something like this. These are throwaway. You can buy 10 of these for $20 or something off Alibaba or AliExpress. Just get in there and through the paint, just go, and it'll go bang, and you'll know that it's discharged. So you don't become the discharge path. Let the side cutters cop that. Or another way of doing it too, I've done in the past, when I'm experimenting, I get something like a 3.3K resistor, and I just solder it across the terminals of that big cap. It's no load to it when it's running, but it'll discharge it and you're not going to get belted. That's a safe way of doing it, but you know, no one's done it, so I do it on my own. So yeah, just be wary of that big nasty capacitor. You know, it's exactly the same as when you see on the back of the old TV sets, you know, the ones with the tubes in them, high voltage, danger, danger. Well, you know, same sort of thing applies. Don't go fiddling it, because it'll, yeah. I had a mate of mine that did a somersault over a TV once, but anyway, I won't go into that. Anyway, catches.